Good morning, all. We'll begin our session within 2 minutes. We're just waiting for the participants to join in. Gemini ma'am, are we good to go? We can start the session now.
Hello, Shani,
Yes, ma'am. Can we start now?
am I audible to you?
Yes, ma'am. You're audible.
Okay, let us wait for 1 more minute.
Okay, ma'am. Good morning, everyone. Welcome to the final day of our faculty enablement program. It's my privilege to introduce today's resource person, Mr. Vinod Venugopal, Delivery Manager, Tata Consultancy Services. Mr. Vinod Venugopal possesses extensive experience in cloud technologies, DevOps practices, software delivery management, and emerging AI-driven engineering solutions. His expertise spans enterprise software development and modern deployment methodologies. Today's session is on cybersecurity, secure software development, and digital risk management. So we are honored to have you with us. I kindly invite you to begin today's session.
Yeah, sure. Yeah, thanks for the intro. Yeah, right off the bat, I must say I'm not a deeply technical person in cybersecurity, but then I've spent sufficient time in this domain to understand the entire landscape, and especially I can bring a perspective of how cybersecurity functions within an enterprise, right? So that's something that I can definitely bring on the table. Okay. And if I may understand the participants are what percentage of the participants would have some sort of like background in cybersecurity? And just so that I'm able to calibrate, overtake this.
So not much, very
Okay.
few.
Okay, fine. All right. Okay. Yeah, cybersecurity from a very personal level, and like to keep this very interactive, because this landscape is evolving, and so many changes. Tools that are relevant, approaches that were relevant, say like 10 years back, are not relevant anymore, right? Say, and it's so dynamic that you know there might be a news on this domain yesterday, which might completely change how we look at this domain today, right? So open to any thoughts from all of you as well as we move along, if you want to add anything that is relevant for the conversation. Okay. Say at a very personal level, say how we understand cybersecurity is, say, as an individual, right? We would have read about and come across so many news articles where individuals receive say WhatsApp messages or emails saying your account is unlocked, your bank account is unlocked, and you need to activate it, right? Especially elder citizens constantly get these sort of emails, right, where generally the tendency is you click on the link, you give your login ID and password. The login page might look exactly like your bank's website. It'll have the bank logo, even probably the WhatsApp message that came, the image will have the bank's logo there, so there's no room for suspicion. So you enter your login ID and password, you enter, maybe there will be some tab which says activate your account, right? You activate it and you are happy, you log out, right? But what would have happened is this entire website might be a fake website, right? Nothing to do with the bank. And these websites are hosted just to get your login ID and password, right? So the damage is already done, right? So that is the typical way how these attacks function. That we have to be very alert, right? As an individual, now because of lot of awareness, lot of these news articles that come up every now and then, I'm sure majority of us in this group won't blindly take that action. But believe me, education, general awareness, none of this really matter, okay? Because even a lot of guys who work in cybersecurity are very easily fall prey to very smart way of attacking. Okay, so we have to be generally alert. Okay, so so this specific incident, what can happen is it will cause us significant stress, because we'll easily lose whatever is there in our account, because ultimately we have given our login ID and password, right? And it can cause significant reputation impact, right? So assume if there is some uh, academician who is very popular, he falls prey to this, right? It affects his reputation as well at a very personal level, right? Another example can be your social media accounts getting hacked, right? Someone can easily log into your account and post whatever comes to his mind, right? So that can really impact an individual at a very personal level, because it won't be easy to connect with your entire social media network and tell them that it was not me who posted. Some might not even believe, right, depending on what you post. So these are things that can impact us deeply on a personal level, and that too it can have a very long term sort of irreparable damage as well, right? So now just extrapolate this to large enterprises, right? So enterprises face the same situation. Enterprises are constantly under threat, because the individuals who attack stands to gain significantly more when compared to attacking individuals, right? Because enterprises have significant resources, the attackers know that. So all the enterprises across the world are constantly under threat, uh, because the attackers stand to gain more, right? And it's the same damage. They have financial impact, they have reputational impact. Some enterprises, in wake of some of these attacks, fall flat, then never recover, right? They would be in a situation to shut down, right? So there are multiple instances of all these happening. Okay. So in the current, say, in the previous era, so probably I should take a step back. Let me share something else here. Oh, hope I'm making sense. There are any questions or anything, please feel free to interrupt me.
So no questions as of now, sir. Please proceed.
Let me try to share something else. Hope this is visible. Okay, so this shows how the cyber attacks have evolved, right? So generally what happens is technology evolves, and humanity significantly benefit from the technology evolution. And unfortunately, the threats also are very closely following this technology evolution, right? So if you look at 1980s, when we had the old desktops and floppy era, precisely the floppy was used as a carrying mechanism for these sort of like viruses, right? So this shows some of the common attacks during that era. Late when internet became popular, the I love you virus, right? This spread globally, and it was very shocking to see how fast it spread even in that era, right? And more recently in 2000s and 2010s, WannaCry, which was very very popular. I think a lot of people got introduced into cybersecurity because of WannaCry. What happened was, our if I'm not wrong, even a lot of desktops in our local self-governance bodies were impacted because of this. So what really happened here is, say, we have all the data in our computer, but one fine day we get a message saying that your computer is completely encrypted and locked, so we won't be able to use it, right, until we pay a ransom amount. It's like blackmailing, right? Until we pay a ransom amount to whoever locked, right? Only if we pay that amount, it will get unlocked. So those threats were prevailing. And more recently, the IoT and connected era were so many, I mean, attacks that you keep hearing every now and then, right? Like, say, something like Colonial Pipeline. This was a a really large attack on a country itself, right? Because the attacks can be at individual level, it can be at enterprise level, it can be at a country level as well, right? So these are events that can have significant impact. So Colonial Pipeline was basically, if I am not wrong, in USA, this company had a oil pipeline from the west coast to east coast, and their systems were attacked. They're encrypted. There was a ransomware, and they had to shut down their oil pipeline mechanism because it has significant threats, right? They didn't know under whose control this was and how they are going to use it, right? So a lot of these gas stations, there are no petrol available for a few days, so it can have very very direct visible impact on us, right? And more recently in AI, I think we'll come to all of this. Yeah, but generally with evolving technology, the attackers also evolve. Okay, so that is a message that we wanted to share. Let's go back. Okay, so in the previous era, say we, especially enterprises, or say like take your college, right? Say any institution or enterprise, it used to function in an office building, right? You have physical security outside. If you are using IT systems, you have a lot of servers which are there in a server room. You have proper access mechanism to into that room, so that not everyone is able to enter it. That used to be the way enterprises used to function, right? But the last decade or so, this has completely changed, especially after COVID, right? Now people work at home. People work through their mobile phones. They check emails through mobile phones, which means your institution and any business enterprise is not confined inside a boundary wall, right? It is literally everywhere, right? Wherever the individual is, that's where the institution and the enterprise is, right? Because you can get into the core IT infrastructure of an institution through a device that an individual has at his home, right? So that's why they say the perimeter is gone, because there's so many smartphones, there are so many IoT devices, there is AI, even your vehicles are connected now, your smart city infrastructure. So the enterprises no longer function in the old way where they were functioning inside a wall, inside a building, right? So which means attackers doesn't need to go and attack a specific location, right? They need to be creative so that they target any of these to get entry into the enterprise, right? So now this is where security becomes very complex, because previously we had to just secure the building and the IT infrastructure in the building, but now we need to have strategies for each of these, right? And generally attackers, what they do, they adopt whichever is the most effective, easy way to intrude. So to give an example, say in physical security, right? We might have proper access. We say, like, we have a building, we have some critical infrastructure, we have proper security and say, like, fingerprint scanning, everything. Assume we like managed everything, but there is a fire exit door that we left open, right? So then it defeats all the purposes, right? Like, the attackers, what they do, they scan this place continuously, and they will be smart enough to understand that we have a flow in our entire process, that we do a fire drill once in, say, like 3 months, but at the end of the fire drill we forget to close the fire exit, right? The attackers will take that route to attack then, right? So similar, the same thing is what happens in the IT systems as well, right? So attackers look for very easy entrance, and smart, coupled with very smart way of attacking, which means, like, these sort of like WhatsApp messages, where we'll be we will never suspect what is coming to us, right? And this is something that we highlighted. Say the central point is, and at an individual level, the on a wider level it will be like enterprise level, and at a larger level it will be countries and humanity. I think you would have recently, we had this attack on the the national test website, right? Of CBSE, if I'm not wrong, right? So that is precisely an example how it can shake up governments, right? So if we don't take security seriously on each and everything, it can have far-reaching implications. And it ultimately it's an individual who is able to do this, right? So attackers just need to be smart to cause damages at any of these levels, at individual level, at organization level, and at country level. Attackers again are like at various of various nature. It can be random individuals who just want to play around and figure out whether they are able to attack. That is one type of attackers. And there are attackers who are really connected across the world, who um, you know who probably are like very passionate in technology, who wants to figure out the latest vulnerabilities and exploit that. That is one, that could be one reason. And there are other state players as well, right? Countries who use cyber attack as another warfare, right? On another country, it's very easy to cause significant financial damage to a country if you adopt this sort of like cyber attacks. And we sort of covered this. This shows how technology evolves and how the threats also catches up with that, the technology evolution. Yeah, and cyber security. When we come to securing the cyberspace, there are three foundations of security. One is confidentiality, one is integrity, and one is availability. And this is typically called CAA triad. So your entire cybersecurity rests on these three pillars, right? And confidentiality means it is accessed only by authorized entities. So it's like if you have your institution, only those who have any purpose with the institution are supposed to come inside. Otherwise they won't be let inside, right? So similarly, IT systems, say your bank account, right? Not everyone can log into a bank account. Either the bank's customer will be able to log in, or bank's staff will be able to log in, or maybe some other government entities, if they have any audit related roles, only they will be able to log in, right? So that's what confidentiality means, that it is accessed only by authorized entities. So if there is a failure to this, there will be a significant leak of data. That's a huge risk, right? It's very similar to our physical security, right? So only those who have any specific purpose from an organization should be entering the premises, right? So similar to our apartments, right? When strangers come in, our security stops them, right? So similarly, our applications should be smart enough to ensure that those who have no purpose with the application does not enter the application. Okay. So another pillar is integrity. So we should ensure that the data which is there in our system is not tampered with, right? Its quality is maintained accurately. So any we should be aware that if some external player comes and changes the data, our system should be smart enough to alert us, right? So if you have your bank account, say your bank account, you have fixed balance by when you get when your salary gets credited, our expectation is that we do a transaction, only that amount gets debited from our bank account, right? So it should not happen that some thousands of rupees get reduced without we making a transaction, right? So that's what integrity means, that the data which is there should be accurate, and it should be untampered and trustworthy, right? Availability is a basic need. Means the system should be available. So like if you try to make a bank transaction, you go to the website, it should work, right? That's a primary need, right? So all these three are critical for cybersecurity, right? So if a secure system means it ensures confidentiality, it ensures integrity, and it ensures availability. Any questions? I hope no. Yeah, and these are say different ways of approaching cybersecurity. There is cybersecurity has multiple pillars. We'll quickly browse through some of these. I don't want to get into too deeply technical, but these are some significant pillars which that you need to know. Okay, so one pillar is called identity and access management, or IAM. This is a very vast space within cybersecurity. So this is precisely about how you control the access, right? So it is a framework of policies and technologies to provide the right users with the correct, approach. I mean, correct, appropriate access to what they need, right? So the different, I mean, I think you would have come across a lot of these things. One is MFA, right? Which means like multi-factor authentication. So previously we used to have, when you log into your bank account, you would be asked the password, but now increasingly you are asked for Aadhaar, OTP, based on your Aadhaar ID. So basically having two ways, or I mean more than one way of authenticating a person, apart from a password, maybe your fingerprint, your iris scan, or an OTP, or you would have typically also come across a question being asked, like what's your first pet's name. So these sort of things, right? Like where you uh, double check whether it's the same person. Yeah, why we do that is because attackers might have gained access to your password, right? So your phone ultimately is with you, right? You have so the attackers won't have access to the OTP. So that's why we give multiple multi-factor authentication. Another one is called zero trust architecture, which means you don't take for granted that someone has access. He is a good entity, right? You follow a zero trust approach where each time you view everyone with suspicion. When I say you, I'm talking about the IT systems. So IT systems constantly vets and validates who is logging. CAA we explained. So multi-factor authentication, zero trust. So this is like a access, right? I mean, you gain through multi-factor, then you follow a zero trust approach, and that's how you protect your resources. So this is the initial access part of it. Now we come to the core applications, right? So application security and data protection. So what we covered was the access part of it. Now we get to how we protect the applications and IT systems, right? So this come under a field called vulnerability management. So what we generally do is say when you build IT applications, you will be doing some level of programming and coding, right? There will be application code to build these IT systems. Then the application is built, and finally the application will have data and will be hosted somewhere, right? So there is something called SAST, which is where you will verify the code itself, whether the code has any vulnerability, whether the code is using any libraries which has a lot of security holes, right? So these sort of things are checked at this level, right? So this is similar to say, like when you have a car, right? You verify whether the car engine, the car components, everything are okay, right? There is no leaks in the oil pipeline, right? So those sort of things, right? DAST is you finally ride the car and see whether it is able to take the corners properly, whether the braking is proper, right? So you don't open the car and check, you run it and see, right? So that's what DAST testing is about. So here it works closely with pen testing. So DAST testing means that you have a web application, you have a set of testers who set the application, I mean who test the application specifically from a security standpoint to figure out whether there are any security holes in the application. Got it, right? So then we have other, once the application is built, we have other mechanisms to ensure that there is no say data leakage from the application. Say like you have a website, okay? You have a website where you are required to upload your photo. Okay, you access a website and you are required to upload your photo. But what if you are able to upload some sensitive document from your institution's network to that same feature where it is the photo is getting uploaded, right? So typically DLP or data leakage prevention, such softwares catch these sort of things so that sensitive information doesn't leave your network and premises, right? So that's where DLP comes into picture. I hope this is not too technical for you and you're able to follow. And if you have questions.
That's okay, sir. We are following it.
Okay, wonderful, good to know.
Sir, there are queries coming in the chat box too.
Oh, okay. Apologies, I missed that. I mean, is it possible for you to probably like pick some? Not seeing queries. I find a comment from Kumaraswamy. Okay, yeah, sure. Yeah, DLP is nothing but data leakage prevention. So here, one thing is a lot of these streams in security. Ultimately, there are smart products in the market. Okay, because over a period of time, this industry has evolved so much that none of the enterprises or institutions build any solutions from scratch for any of this. Okay, because there are ready-made products available for everything in the industry. Okay, so typically data leakage prevention, softwares, what they do is it will allow you to configure a lot of rules. So say a student, right, who logs into the portal will be able to upload only certain type of information, right? So similarly, a professor who logs in will have probably much more lenient rules set up so that he is able to, I mean, he is required to do upload a lot of things as part of his role, right? So such sort of rules are mentioned, I mean, configured in the DLP solutions. So the ultimate goal is that any sensitive information should not leave your network or your mission or your IT infrastructure. That is the whole purpose. Okay, so, I mean, another example could be your email, right? Say when you send email, I mean, some of the IT companies don't allow their employees to send any email outside their network, right? But some users might say, like the recruitment team of the company, right? The recruitment team has to reach out to individuals who are outside the company for hiring, right? So which means for anyone in the recruitment team, the DLP rules should be such that only those individuals in the team are able to send emails outside, right? So those sort of rules are set in DLP. Similarly, attachments, right? You can write rules saying the attachments won't be allowed, right? You probably can send an email, but just to be careful that none of the sensitive documents or code snippets are sent out, the DLP will prevent that in the email itself, right? So that's what DLP means. Masking, I'll come to this later, but generally what it means is, say you have data in your systems, you mask that data so that even if someone manages to get your data from your database, he won't be able to make any sense of it because it is not in a proper format, right? I mean, only you will be able to unmask it with some methodology that you have, right? So anyone who gets the data won't be able to use it. right? That's the intent. And you won't believe, I mean, we generally, there is a tendency to perceive security as, something like in the virtual world, hitting large enterprises like, Bank of America. But this is not the case. I mean, this is very real. Say a lot of businesses, hospitals, that we have in our city, lot of their data are getting stolen, right? I mean, our health records, I mean, so a lot of these things are available with bad players, right? So they are able to sell this data also. Okay. So it makes sense to have good DLP and masking policies, so that at least if the data is sold, people who gets hold of the data is not able to make sense of it. I hope that answers the query. I hope I clarified you, Neetu. No, that was a question. Take silence as an yes. Moving on. Yeah, this is again another strategy in cybersecurity, continuous threat exposure management. So what enterprises do is, it's not enough if you build this, if you have a DLP solution, and if you have a masking solution, and if you have an IAM solution, just build it and leave it. No, that is not sufficient, right? You have to constantly, operate it also. You have to, start collecting security related, data from each of these each of these systems, and constantly evaluate, okay, this IAM issue is coming up. Is there a risk to my data because of that? So you have to constantly, keep on pulling this information from various systems, then assess that against the actual risk that you have for your organization, right? So different organizations, because of their nature, will be wired very differently, right? Say an access related risk for one business, the same technical risk might manifest very differently from a business sense for two institutions, right? So you have to constantly assess the technical security labs against what is at stake for a business constantly, right? So you have to constantly calculate the risk, what can be the impact on my business constantly, and then do a course correction. So say the same technical you know error or security flow, an organization A might look at that technical error or security flow deeply, but it might come up with a finding that, okay, we understand the security flow is there, but it appears the business impact because of this technical flow, because of our nature of business, is very less, right? And it might decide to live with that issue, right? Because it has already assessed that there's no significant business impact because of this. The cost to fix is probably like very high, but the impact is very minimal for us, right? But some other institution or business might evaluate that this and figure out that this specific issue is at the center of their operations and it can hit their entire business, right? Then they would prioritize this as a significant issue, and they would try to get it fixed immediately, right? So which means they would need to mobilize a group of technology professionals and get it fixed immediately. Okay, so there are solutions available for CTEM as well, where it gives a holistic view of risk, where there are issues, whether all the priority risks are getting resolved, when it is getting resolved. So the management of the companies get sort of like a very holistic view of how the risk management is happening within the organization because of this. if there are questions, just give me a shout out, okay? Because I am on this presentation mode, so I'm unable to figure out if there are questions. Okay. So another way of managing security is operations. Okay. So under operations, there is something called SOC. This is typically called SOC, Security Operations Center. So this is a group of security experts who would basically constantly look at security events. Okay. So there are again tools which will pull in a lot of the security events and alerts, but ultimately someone has to sit and look at these security alerts and events, right? So this is typically a 24/7 team in all enterprises because we cannot miss any of the security alerts, right? So they will constantly evaluate. When they get a security alert, they will check whether it is correct or not, whether it's a truly a threat or not. I mean, truly a security event or not, and then take some action. Either they might pass it on to an IAM expert, or they will pass it on to a DLP expert, and they'll take action, right? So that's what Security Operations Center is about. Threat intel is a slightly proactive posture. I mean, here we don't wait for a security event. This is more proactive in the sense, like, you will have an intelligence team who will go into dark web, who will generally go into a lot of platforms where you can get information on the most recent threats, right? Or you generally see, like, say, if you are say if you are a hospital, right? If you are managing a hospital, right? Generally what you do is, like, you generally look out in dark web, you generally look for other platforms that track healthcare sector and figure out if any other hospitals anywhere in the world has got attacked, right? So if someone has got attacked with a malware or some security cyber attack methodology, you figure out who has attacked, who you figure out how they have attacked, what is the methodology they have used, what are their demands, who is behind this. Is it an state player? Is it an individual? Do they have presence in your region, your country, your locality? What are the the chances of you getting attacked in the similar manner, whether you have proper cyber security mechanisms to prevent it if it happens, right? So that's what threat intel is. This is slightly proactive sort of a posture. So this is sort of like summarizing what we said: IAM, the access controls, vulnerability management, which is about application security testing, the SOC, which is Security Operations Center, threat intelligence, which I said, proactively capturing this sort of threat, CTEM, which is continuous threat exposure management, organization constantly looking at their risk management and doing course correction, right? So I think one thing that we didn't cover is GRC, governance, risk, and compliance. Okay, so here GRC is sort of like an overarching sort of an approach. So this is where all the processes and policies and guidelines for security are maintained, or these are the guys who instruct everyone, right, and instruct the organization on how to function from a cybersecurity perspective, right? So a typical example, you say, like, you all of us know that if you don't take care of our teeth, right, the teeth will decay, and it'll cause all sort of like teeth pain, I mean tooth pain, and all sort of like health issues, right? Probably like even can result in heart issues as well, right? And we know that every day, like, you have to brush twice, right? So if there is a if you eat, you need to clean your mouth, wash your mouth after that, right? So this is already there, right? So someone has to there is a process to be followed, which means, like, brush your teeth twice, wash your mouth after taking food. So these are the processes. If we follow this, then we are sure that our tooth will be healthy, right? So GRC is the same, right? This is where all the processes about security are listed down, right? So organizations, if they follow, they'll have a very mature security defense approach, right? And this space also has significantly evolved. There are multiple ways of approaching this. In US region, mostly NIST is prevalent, and this is generally formulated for their government entities, especially for government contracts and all. NIST is sort of the guidelines that is followed. So it has core pillars, basically, identify, protect, detect, respond, recover. Like if there are, security threats, you should be smart enough to, identify where these issues can come, and you should be smart enough to protect them. You should be, smart enough to detect if something happens, and you should be able to respond, and you should be able to recover. So when you say recover, recovery is also critical. Say you have a ransomware, right? Assume you open your laptop one fine day and find that you are unable to use the laptop because it has got locked by someone else, and they are demanding a ransom, right? What do, right? uh, because when someone locks it, they have a key, and the key is with them, right? Unless you pay, there is no way you can access your laptop, right? So for enterprises also, it's exactly the same, right? So someone locks your data, there is no way to get it back, right? So in such cases, what they typically do, there are a couple of ways to there are costly ways of decrypting it. And generally what the industry follows is, you will have backups, right? You would have different backup mechanisms also, where you don't store your backup in the network. There are multiple ways of doing it, right? So typically what you do is you recover from your backups, right? So that's what typically business entities do. Yeah. So what I was saying is, like, so this is a set of processes and security controls and instructions and guidelines, right? Which would explain how businesses have to protect their data. So this entire thing falls under governance, risk, and compliance, right? So in US region, it is NIST that is generally followed. Globally, and especially in Europe, it is ISO 27001. NIST is very relaxed in that it doesn't tell you exactly what you need to do and how you implement. It just like lays down these sort of like principles. Whereas ISO is very, very specific. There are a set of like rules for IAM, for data protection. So it tells you very clearly that you need to have, say, like multi-factor authentication implemented, right? And you also should be able to demonstrate and provide evidence on how you have done it. So typically you can take ISO certifications, and there will be external auditors for this as well. They will come and audit you. At the same time, you get, this is also a brand as well, right? I mean, when you run your business, you can say that you are ISO 27001 certified, which means someone has come and audited you, and you're following this entire process, right? So business and this go hand in hand. Unless you secure your data, your customers won't trust you as well, right? So it makes sense to follow these sort of like principles as well. And especially for organizations where, say, like, we have no idea on security, right? At least you take this ISO 27001 and you will clearly understand what is required to be done and why these controls are there. Okay, let's move on. The graphic. Yeah, I think AI, I'm not going too deep. Some of this you will also know. Deep fake social engineering. I think you would have, heard about this digital arrests and these sort of things where, people who are who appear to be in some police station give a call to you and, demand, saying that some your, parcel is stuck somewhere and there's some drugs in it. You need to pay this amount, blah, blah, blah. So basically, this is also aligned to what we discussed earlier, that with evolving technology, unfortunately, the latest technology is also very democratized, and it is also in the hands of the bad players, right? So which means the cyber defense team also needs to quickly get their acts together and defend the IT systems as well, right? So another thing with I think a lot of you would have read about this mythos as well, right? So where it's an AI LLM, right? So what has happened is, say, in security there are so many vulnerability management products which will basically scan your servers and figure out your servers and softwares and figure out if there are like vulnerabilities, right? The security holes, basically it will figure out if there are any security holes. But what mythos has managed to do is, using AI, it has now gone and figured out so many security vulnerabilities from the past, which existed for almost like 2 decades and which no one was aware of, right? So typically, what happens is all these security vulnerabilities or security holes are recorded in something called CVE database, which is like, I think, common vulnerabilities and exposures. So earlier, I think, say, every month, probably like 10 to 15 vulnerabilities were getting captured in this database, right? Because ultimately you need to sit and research all the products, all the OS, and figure out security holes, right? So a lot of researchers, they do this work painfully, and then they add, when they figure out a security vulnerability, they get this added into the CV, right? Then what organizations do, they constantly look at the CVE database. When they find a new vulnerability added, they quickly check whether they are using this product in their organization. So if they are using it, the product, it means that anyone can ultimately exploit that vulnerability and attack their systems, right? So the moment a vulnerability is added in the CVE database, you need to have a strategy to fix it. So typically what the product vendors do, when the product vendors find that there is a vulnerability reported against their product, they will immediately look at finding out some fixes and release a new patch, right? And organizations, what they do, if they are on the top of this, they will constantly wait for this patch to arrive, and the moment the patch arrives, they will quickly upgrade the software or run this patch, right? So that that security issue is resolved, and then like nobody is able to attack them based on that security flow, right? So that's how this functions. Okay. Yeah. So, but the problem is with mythos now. What is happening is mythos is discovering so many vulnerabilities in like thousands, right? And all these are getting added to CV currently, right? Which means like so many product vendors are working around the clock to find fixes for these vulnerabilities, right? And which means like organizations also have to run so many patching, right? So that their systems are secure. So I think while mythos is capable of finding out these vulnerabilities, it also means that attackers are aware that there are now thousands of vulnerabilities that can be exploited, right? So this is a significant political discussion also now, because now USA is trying to prevent this being used outside of their country. So while say like Anthropic and these sort of LLMs are increasingly getting marketed and being adopted globally, so suddenly we have a country who is worried that this can very easily get into the hands of bad actors. So they're trying to secure their systems in their country, right? So the very dynamic space here. And one more thing is the company itself decided not to release it, because if it releases this, then all these vulnerabilities can be exploited. So they are releasing a defensive sort of a product which companies can use, without without any of these, how do I say, and without any of these features where it can be attacked, right? They're releasing a version where there are some security guardrails on top of Mythos, right? So that is also going on. Okay, I think I'll park this for time being. Yeah, so just to summarize, so as I said, like previously we had business entities who were, prone to attacks, but now every individual is an attack surface because, he carries a smartphone, he carries the devices, he can carry smart cards. So that's one angle. Another aspect is how, threats and cyber attacks, they, go hand in hand with the technology innovation. And proactive and layered defense is mandatory, like, using all these strategies that we discussed. Okay, I think I covered pretty much I had to. Any questions? I think I'll open the floor for questions. Some more topics we covered, but I think it'll probably take a small break. Before that, in whatever I've covered, right? If there are any questions, I can take that. I hope no questions then. Let me take another one.
Hello, sir.
Yeah, was there a question?
No, sir.
Okay. Yeah, I'm just sharing another deck. Yeah, this is slightly more technical on how enterprises, approach security. But I think a lot of this we have already covered, so you'll be able to relate to what we already discussed. Okay. So what I said earlier, how.
So we have a question in the chat box.
Okay. Yeah. Thank you for prompting. Oh, I mean, there are several actually. Say like ISO 27001 itself. Like if you follow, right, or NIST, website. I mean, these are very good places to refer to because these are standard and authorized entities, right? And ISO will have these sort of like very clear definitions on each of these controls. Okay. And I think so many YouTube videos and so many good tutorial videos as well available. Okay. Yeah, but one thing is, I think you need to generally keep a tab on the technology landscape, especially this daily tech capsule sort of thing, right? Because it's evolving so fast. Something like Mythos is sort of like shaking up everything, right? So we have something called 0-day exploits, right? which means there is a vulnerability. Assume like Windows or say like Google Meet has a vulnerability. Okay, say this vulnerability got identified. So typically, what happens is when a vulnerability is identified, till the time of fix comes, it can be exploited by anyone. That's what it means, right? So which means from the time the vulnerability is identified, the developers of Google Meet needs to go and figure out why this has happened. They have to fix it. They have to test it. They have to develop it. They have to test it. They have to roll out this into production. Then all the users who around the world who are using Meet needs to know that there is a vulnerability. They have to upgrade to the next version. We generally don't do that, right? Like we use a product, we just use the same version, right? We never upgrade, right? But enterprises, unfortunately, they have to keep a tab of what is going on, right? So that's why all these like governance mechanisms and CTEM and all these are so critical, right? So any small vulnerability in any product, if there is a patch available, they need to get it fixed, because the moment the vulnerability is identified, it can be exploited till the moment it is patched and upgraded, right? So so that's why it is very critical. So the space is very dynamic. So you need to refer to multiple sources to keep up to pace. But on the standard streams of security and these sort of things, I think NIST and ISO is what I would suggest. Okay, so I think this we covered to an extent. So how enterprises generally address security is a multi-pronged strategy. One is network security. This is very critical because this is the first layer of defense. So any product or applications that any business entity or institutions have. So this is the first line of defense, right? It is within the network that everything will be there, right? So anyone has to access any IT resource or systems that belongs to you. At first, it would need to come to the network, right? So that is very critical. Then identity and access management that we discussed is about gaining access into your system, right? uh, Data security is about the data which is there available with you. How do you secure it? Whether you encrypt it, whether you mask it, whether how you prevent sensitive information from leaking your premises, those sort of things. That is data security. Vulnerability management is what we just discussed. Some security holes in the products and applications that you have, right? So how do you manage those risks? How you patch it? Those sort of things, right? How you do the security testing of the application? Those come under vulnerability management. Security operations, again, we discussed, is the central team who constantly looks for security events and logs and take action based on that. Threat intelligence, the proactive posture of scanning for collecting intelligence on various threats prevailing in the market and constantly feeding that into your organization to figure out whether you have any risk as per that. And GRC is all the standard set of practices and guidelines for security. So it goes slightly deep into this identity and access management. Yeah, so this is multiple phases. One is authentication, where you check whether it's a right user who is coming in, right? You check in terms of your password, your OTP, these sort of things, right? So this is where the authentication happens, typically to ensure that's the correct user who is coming in. Authorization is granting system rights based on strict segregation of duties. So like I think we discussed this about students having students and probably like professors having certain type of access when compared to some other like probably vendor who is coming in, right? And role management, yeah, this again, like when in a bank website, when you log in, you either log in as a user role, or you log in as a bank staff, right? Depending on different roles, the screens that you find will be different. The type of access that you will be having will be very different. So these are all comes under IAM topics. And recertification, this is also very critical, and this is now this is taken up very seriously as well, even in government entities. So typically all your you would see like all this KYC and all in banks like happening periodically, right? This is typically to figure out whether whatever access that this person has now, does he still need that access, whether he is still required to be part of that system. So this gets periodically verified. So you don't just give an access and leave it, you check it periodically, right? Because it might so happen that, say, someone who was working in one department has moved to another department, right? So uh, generally what happens is, people will take uh, this person would have got access to the new department, because when he joins the new department, for his new function, he would need access to various things. So typically people will give that access, but there generally the slightly relaxed way of treating revocations, right? So his previous department might not have revoked his access, right? So those sort of things are caught in recertifications. Moving on to data security, slightly deeper. There is something called public key infrastructure. So this is the foundation of your masking and encryption and these sort of things. So this works on the principles of complex mathematics algorithms, right? So ultimately what happens is, like, if there is data and if the data has to be encrypted, it uses Max principles to lock that. Okay, which means if it has to be unlocked, the current computer systems will take thousands of years to crack it, right? So that's why these are very, very safe. So all our transactions, the data that goes through the internet, your banking data, so everything, right? So all these are encrypted using this these sort of like technology infrastructure, right? Public key infrastructure. So data, again, data can be at data at rest, data in transit. Data at rest means, say, like, you have data in your database, right? That's data at rest, right? So these are generally encrypted. We generally use something called KMS. I mean, we don't need to get into these many details, but like the data at rest are encrypted. Data in transit also has to be encrypted, because ultimately when you get your bank information from a bank website, no one should be able to peep into that information and try to make sense of it, right? So we use encryption there as well, and there specifically PKI is significantly used. Public key infrastructure is significantly used, and those in the middle won't be able to make sense because these are encrypted using very complex algorithms. Okay, and even if they try, their computer systems would take like thousands of years to break it. I mean, might be able to break it, but it will take that much time, right? This again is like infrastructure, related to security infrastructure. Yeah, this we discussed about DLP, data protection. There is another concept called database, activity monitoring, or DAM. So this, if you have a database, the main aspects of the database, say like data admin password, if it gets changed, right? Or if the database backup is suddenly not working. So those are of like very critical database events are captured using database activity monitoring systems. Okay. So another aspect of data security is insider risk management. So these are, say, systems that are targeted to sort of high risk individuals, say someone who resigns from the organization, right? So his the level of monitoring on this person unfortunately has to be more than on the general crowd, right? So those sort of things come under insider risk management. Okay, if you see like behavioral analytics, if he's taking so a lot of information downloads, if he's downloading anything sensitive with respect to the organization, so these sort of things are captured under IRM. And IRM also works closely with DLP because these sort of individuals might get interested with additional rules in DLP so that the data doesn't go out from such individuals' hands. I'm just taking a pause. I think, can we take a short break, if you don't mind?
Yes, sir.
Okay, yeah, just 5 minutes, okay? And
Yes,
then
sir.
pause questions also if you have meanwhile, okay?
Dear participants, if you have any queries, you can post it in the chat box.
Hi, welcome back. Follow reference on a specific cybersecurity. Mm, yeah, to be honest, Sajid, I mean, I don't know whether one specific link, because I think a lot of these, I am keeping tab from news articles and general tech forums, right? Because mythos is everywhere. But let me get back as well if there is anything specific, because this space also is like very, I mean, evolving, right? I mean, this mythos hit us very recently. So there's I doubt if we have such platforms which is dedicated to this, but I'll get back. Okay.
Thank you, sir.
Yeah, I can share the PPT. Yeah, LinkedIn as well. I'll share with you. Okay, I think we'll continue from where we left off. Interest of time. Till what time what was the plan? I missed that actually. Was it 12:30 that we had the schedule today?
The session was scheduled till 12:30, but we
Yeah.
can uh, we can be flexible. No issues.
Okay, got it. Yeah. Just try to be sure that you're able to complete. Okay, just sharing again. Yeah, I hope you're able to see the screen, right?
Yes, sir.
Okay. Okay, so just a quick recap. We covered identity and access management, which is about authentication, multi-factor authentication, authorization, role management, and recertification. Then we cover data security, which is about public key infrastructure, how we encrypt data using complex, math algorithms, and how we thus secure data at rest and data in transit and infrastructure. We also spoke about data loss prevention again, how we set certain rules so that we are unable to uh, you know share any sensitive information from our organization to outside world, how we are unable to send emails with attachments. We also spoke about DAM, which is database activity monitoring, which is about any critical database, related events, admin password change, admin user change. These sort of things get captured. IRM, which is insider risk management, where high risk, profile users are very separately monitored, and there are policies related to them being configured through DLP, etc. So now we move to vulnerability management. Okay. So vulnerability management, as I said, the globally there is a list of top 10 vulnerabilities which are published periodically. Okay. So this is called OWASP top 10. Okay. So which is nothing but, especially for websites, what are the top 10 vulnerabilities, right? So in the sense, like there is a vulnerability called SQL injection, right? Where if you say you have a bank account, okay, assume some cooperative bank, they come up with a website. Yeah, it has a user ID and password field. In the user ID field, if you, instead of your username, if you type in a specific SQL query, for a lot of websites which are not properly designed, it is possible to query your database through that username field itself, right? You will be able to get access to their database, and slowly you will be able to get password for the admin from that database. So there are ways of doing that if your website is not properly designed, right? So that is just one example. So similarly, there are every few years this such top 10 vulnerabilities are constantly updated in this list, right? So typically what organizations do is they test all their applications against this top 10 vulnerabilities, right? And they ensure that at least these top 10 vulnerabilities are taken care of for their applications. They are tested, they have ensured that none of these 10 vulnerabilities exist for their application, right? So that's why this is done. And as you see, like penetration testing, it's called penetration testing, where you test your applications against these top 10 vulnerabilities. Not just this 10 vulnerabilities, because especially there are some of these vulnerabilities that keep moving out of the list, and another one will come next year. So if you're really serious about your business, you would want to restrict to just this 10 vulnerabilities. You will test the other remaining ones as well, right? And 0-day, we explain, say, vulnerabilities. When you say vulnerabilities, ultimately a security hole, right, which can be misused. The word we generally use in the security parlance is exploit, which means a bad player uh, figures out a vulnerability and exploits that to get entry into your IT infrastructure. And we quoted one example of how for physical infrastructure you will gain entry into the building through fire exit, right? Something similar, right? So any one small vulnerability that you have not taken care of gets exploited by a bad player, and he would gain access to your entire systems, right? So 0-day vulnerability, as I said, is any vulnerability that is for which the product company has not released the fix yet, right? So those vulnerabilities are ripe for any attacker, right? Because there is no fix available, and the attacker knows that these vulnerabilities are there, so they know that they will get entry into any system who is using this product, right? So that's what zero day vulnerability means. And security testing, yeah, this I think we covered earlier. SAST is static application security testing, and DAST is dynamic application security testing. This we related to the car components being verified, right? Something similar. So you check at a code level whether in the code itself if there are any security flaws, whereas DAST is you basically are given with the application URL. You are not, say the tester is not given access to the actual code. The tester is given only the website, right? So with the website, the tester tries to penetrate into that application and that try to run the test. Yeah, especially DAST is done automatic fashion. It's not like manually done. SAST and DAST are automated testing using solutions. There are like tools available like burp suite and all that we use for testing code and testing the actual URL as well. And I suppose a lot of you would have heard about DevOps, which is in the previous world, we had software programmers who would write code. Then there will be testers who will basically test the functionalities. Then there will be a deployment team who deploys this code into production, right? So in DevOps, this entire thing end to end is automated, right? You develop the code, it gets built and tested automatically, and it gets deployed automatically, right? So that is the reason something like Amazon is able to deploy so many releases in 1 month, right? Because the speed of upgrades and deployments have hugely changed because of DevOps. Because when you are writing a code, it's getting compiled, it's getting built, tested, so everything is automated, right? So you're able to deploy so many more features in a short period of time, whereas previously there was a break between each of these phases. Once you develop, you have to take it to the testers, then you have to take it to the deployment team, then it is released into production. So now all this is automated. So from a security angle, what has happened is now security is also part of this chain, right? So previously, what used to happen, even in DevOps, once you deploy everything, then you figure out, okay, your business functionalities are working. You have so many functionalities getting released now, but there is a huge security hole, right? Then it becomes a problem. You have to do a firefighting. You need to, close the security hole. So now what is happening is security is getting integrated into this entire DevOps pipeline, right? Which means at a code level, at development side, you have SAST, right? Then at a build level, you ensure, whatever, infrastructure that you have, that is like secure. So in testing, you again like check whether, the security angle is completely tested, whether your login has multi-factor authentication, that is getting tested. So ultimately, your security is also part of each of these DevOps phase, right? And the earlier the better. Because if you figure out some security related hole in the development phase after the application goes live, it becomes so difficult to fix it. It becomes costly to fix it, right? In fact, even in design phase, say something like using multi-factor authentication, that's a design question, right? You cannot have that discussion after the application goes live, because the change will become any change to the application will become such a time and cost consuming thing, right? Because you need to change your entire design after everything is deployed. And this we discussed about. Yeah, give me just a second. Apologies. Somewhere here. Apologies. Yeah, so we were at vulnerability management. We spoke about CV database, OWASP top 10. We spoke about pen testing. We spoke about zero-day vulnerabilities. We spoke about SAST, DAST. We spoke about DevSecOps. That's what it is called. How we sort of like intertwine security within DevOps. Yeah, this again CTEM that we discussed, how we constantly assess security risks and do a course correction, right? And we also discussed about there is something called CVSS score, which is nothing but each of the say new vulnerabilities that are sort of like identified globally. There is a risk score attached to it as well. Okay, that is again based on multiple parameters, in the sense like how easily attackers can exploit, or whether there is a complexity involved in executing any exploit from that vulnerability. That could be one factor, right? Because if it is very easy to run any exploit with that vulnerability, uh, chances are more it will be like used by large number of attackers, right? So that will have like more a higher CVSS score, and these are generally scored from 1 to 10 if I remember it correct. So a very high score of like 9 would mean it's a very high risk item, right? So similarly, each vulnerability is scored risk wise with a CVSS score. Okay. And as I also explained, ultimately it's up to the organization to decide and prioritize, because some organization might prioritize a vulnerability with CVSS score of 2 over something with CVSS score of 9, right? Because the organization might perceive that even the vulnerability with CVSS score of 2 has a significant business impact in their context, so they might prioritize that over something else, right? Security operations. Moving on to security operations. So here we have something called security information and event management, or SIEM. And you also have something called security orchestration, automation, response. So SIEM is nothing but this is like a central junction where all security events, alerts, and logs and everything gets fed into. Okay, so this is a central platform that the SOC teams will ultimately operate, where every security event will come, like alert, or it can have like genuine issues. It might not have. It might have issues which are not really relevant. So ultimately, the SOC team is the team who will decide whether any action is to be taken or not, right? And beyond that, now there is another layer called SOAR, which basically is a lot of this action that the SOC team takes can be automated. So that's what SOAR is about, right? So it reduces the effort of the SOC team, and triaging, all those it reduces, right? It is able to take the corrective action also itself, right? Say some of the automated playbooks it will run. Say if there is an alert saying that this specific host is probably like attacked, and we need to take it offline, it might isolate the host by itself, right? Revoke access. So all these actions SOAR is able to take itself without any other manual intervention, right? So these two are critical parts of the organization now. If you don't invest in SOAR, ultimately you will have to keep on investing in SIEM and the security operations center, because your logs and alerts are going to be ever increasing with so many cybersecurity systems. Yeah, this is again another strategy. So this generally a lot of organizations use this. So red team is nothing but it's you can assume it like a set of real um, attackers within your organization. Okay, so the organization will uh, have a team called red team who would sort of like simulate a real attack. Okay, so they would actually internally host a fake website, right? They will send phishing emails. When you say like phishing is phishing, so these are emails that you would be sort of like enticed to click on, but there will be significant bad effect of clicking it, right? So typically what gets sent is something like, say, there are gift coupons for employees available, something like that, right? If you click on this link, you will have some employee gift coupons that you can use at like some mall or something, right? You click on it, then what will happen is you'll get a message saying that you clicked on uh, uh, probably a like harmful website. And typically this will have an impact also. Mostly you will lose your access to your system for a day. You would need to undergo some security training, right? So the organizations are creative with this, and this is generally done to increase awareness about security, and also ensure that generally the employees are generally alert, right? Because whatever security deep technical expertise and products you have, the weak link generally is that the users are not alert enough, right? And unfortunately, in the current world, when everyone is able to have some sort of like deep access into the systems through their phones, it's very critical that individuals behave responsibly from an IT usage perspective, right? So that's where these red teams come into picture, because they constantly try to attack the stuff and figure out holes, and then they come up with the reports as well for management, saying that okay, we are finding people in this department not adhering to standard practices or security guidelines, right? So this gives organizations deep insight into which departments they need to focus more on trainings and awareness, or probably put more security controls in place, so that even if people click on something, it doesn't cause any damage, right? So that's what red team is about. Blue team is more about defensive, like if there are so many security alerts and these sort of things or threats, generally they look at how to protect the organization from that. So they don't directly reach out to like staff and attack or anything. So it's more defensive in nature. I think the data security we covered, not data security, apologies, threat intelligence. Threat, I think you don't need to go deep into this. I think threat intelligence, there are, say, ways of collecting details on threat. One is like open source intelligence. This shows threats about open source product. Then dark web, if you access, say, you'll get a lot of information, especially what sort of like data is coming, whether you're getting like data about manufacturing. Like I think recently there was an attack on Royal Enfield, right? Where a lot of their sensitive information was available with some bad players, and they're demanding ransom, right? Similarly, I think JLR had an attack recently, right? So typically it's about collecting intelligence, okay, on different entities, and then figuring out whether it has any impact on yourself, right? So here, if you scan dark web, you will figure out like this identity of bad players, what their motivations are, what techniques are they using. So these sort of like you'll be able to do a mapping, and you will be able to do a mapping on your organization as well, on whether there is a chance these sort of like entities might attack you, whether their motivations are aligned to your business, function. So typically, it's these sort of analysis, that comes under threat intelligence. Going very deep into all this, GRC that we discussed is about controls, and NIST also we discussed at a high level. GRC specifically has so many controls. It has, again, like all these controls that we discussed about IAM, right? IAM controls will be there. Then recovery standpoint, there will be some controls saying, say if your organization, all the data is, say, in Kochi currently, right? So what will happen if there is a flood in Kochi and it affects the data which is there in your Kochi location? Like what if your server room gets flooded, right? So then ideally you should have a backup site somewhere else in some other city, right? And your application, instead of pointing to the data in the Kochi data center, should point it to, say, the data center in Thrissur, right? Something like that, right? So that's called business continuity, or DR, disaster recovery. It's also called disaster recovery. So there, ISO will mandate saying that annually you would need to do one disaster recovery test and prove that your business and your IT systems are able to function normally during a DR event, right? So for that day, what you will typically do is you will make your application point to the DR site in Thrissur, do a test, demonstrate that you are able to do exactly the same, function of the website from the Thrissur DR site, and provide evidence and get this test as passed, right? So similarly, ISO mandates multiple, security controls. Say, patching, especially operating system patching. Whether you have the latest, patches that are released, applied on your systems, right? IAM, whether you have used, multi-factor authentication. On database, I mean, data security side, whether your data in the database is encrypted, right? So these sort of things gets checked there. Yeah, this is sort of like a fascinating thing, right? Ultimately, so if you look at ISO controls itself, there are hundreds of security controls, right? So how do an enterprise, decide, how much security, right? So it's a crucial, decision point, right? Because you can keep on investing in security also, right? So you have to weigh what is your business interest and your business outcome, and weigh how much security you need and what security is relevant for you, right? It doesn't make sense to take the ISO 27001 and implement everything, right? Because some of it might not be relevant for you itself, right? And your enterprise philosophy also matters, right? So if your enterprise business philosophy is that we are a low cost business providing service cheap, right? Then it doesn't matter for, I mean, it doesn't make sense for you to invest significantly in all security products, right? Because you have to take that minimalistic approach for your security operations also. Otherwise, what will happen is the security cost will significantly creep up, and it would have an impact on your business operation, right? Because the cost has to be adjusted somewhere. So these are decisions that has to be taken. And one more thing is that security, generally the security investments get triggered either from a CISO. I mean, CISO is generally the head of security, okay, chief security officer, or it's also called chief information security officer, CISO or CISO. So if you have a CISO who has significant experience, say from various attacks, then typically he'll have an approach on how to define the security standards for the organization. So that is one way the security programs can come into your organization. Another trigger can be any attacks that happened recently, right? Like any attacks that is prevailing in this industry or this region or this country, right? because of that, you would need to take up some security programs, right? Because you already know that there is a, this risk that this can happen. So that is another, trigger for security. The third trigger can be these sort of certifications and audits and, standards like ISO, right? Where you're shooting for an ISO certification, or, you're required to demonstrate that you have the certification to get some large, business deal, or whether you have to get into some Europe region, you're required to have this certification, right? That's another trigger for, this sort of like security investments. Yeah, and some of the new, emerging sort of areas in security. One, of course, as we spoke about, mythos and artificial intelligence, but equally fascinating is, AI agents, right? So AI agents are going to do a lot of things going forward. They're going to be decision makers. They are going to, do a lot of things autonomously. They're going to orchestrate a lot of things without human intervention, right? But how do we manage the access to agents, right? So what we have for IAM currently, for users in IAM currently, the entire IAM for agents also is a hot topic, right? Like, how do we manage user administration? How do we recertify agents, right? So these are all like evolving sort of ideas, and a lot of researchers happening on this space, right? Another critical part is post-quantum cryptography. As you know, a lot of research work happening in quantum computing, right? And I think there are guidelines given by Google saying that by 2030 or so we will be like quantum ready, right? And they've demonstrated the capability multiple times, right? So this carries a significant risk in terms of data security, because our entire the current internet, the entire businesses, all enterprises currently operate with the understanding that the current compute power cannot break the encryption mechanisms and masking mechanisms which are there, right? I mean, what we discussed in data security earlier, especially this, these ones that we discussed. Yeah, and all the data at rest and data in transit, the PKI infrastructure and encryption based on complex mathematical models is a foundation of security, right? So previously, currently the compute power, it takes thousands of years to break this, but with quantum computing coming in, it might be able to break this in matter of minutes, right? So which means whatever we have built till now, all these have to be relooked, right? Because if quantum is going to break that within a fraction of minutes, it means like whatever transactions you do, anyone will be able to basically have access to it, right? So the entire enterprises, everything would need to re-look at encryption and how to address this in the light of quantum computing, right? So there are again a lot of research happening in this area. I think it was NIST who had coordinated a lot of algorithms for cryptography for a post-quantum world. And now there are some algorithms which have been shortlisted, and now some of the banks, especially like in the banking industry, they've started implementing cryptography and encryption for a post-quantum world, which means even if quantum computers come, they also won't be able to break these encryption algorithms. But it is easy said than done, because we are talking about vast enterprises landscape, so many applications. So each and everyone would need to adopt this. They would need to redesign their current systems, ensure they adopt this one, right? So it's a lot of work to be done on this. And typically, I think you would assume that large enterprises function in a very structured manner, but believe me, that's not the case. I have personally seen instances where there was one, large global bank who had a set of researchers working from researchers working from a remote location in US who are very passionate about technology. They used to build a lot of like business applications at short notice. I think they're created some of the web applications for the bank, and it was in production, and it was hosted in a server. It ran for a while, and after that, the business application was not required beyond a point in time. So it was brought down, and that server was to be decommissioned as well. So we shut down the server, and we were planning to decommission it, but we realized there was suddenly a huge noise because some other critical application had gone down. And only on that day we realized there was a critical business application that was functioning from the same server without anyone knowing, right? So these sort of like a lot of informal things happen within the enterprise world. So that's why these sort of like processes are also very important. Governance, risk, and compliance. Ensuring that you properly record your infrastructure estate, your application estate. You have proper recordical footprint of your applications, IT, and business landscape, so that you ensure that security also reaches each and every corner of this, right? So yeah, I think come to the end of it. I hope I managed to cover the entire, at least the breadth of security. It's a very vast topic. So in the interest of time, I think we'll stop it at this, and more than happy to take any questions on this.
Dear participants, if you have any more questions, the platform is now open for questions and discussions. If you have any more questions, you are welcome to ask the questions now. So I hope all queries are answered. Before we conclude, we kindly invite the participants to unmute your microphone and share your thoughts and experience regarding the 6-day faculty enablement program. If you have few participants who can unmute your microphone and share your thoughts about the 6-day faculty enablement program, it will be really good.
Regarding Vinod's session, it is really very covering the entire breadth. And sir, the academia has yet to experience that level of security in their in our day-to-day academic work. And what you have an enterprise level, we are yet to expose to such kind of responsibilities and work, and very few are getting into that level right now. And your session would be helpful for them as they scale up. Thank you so much, sir.
Thank you. Yeah, thanks for the feedback. I think especially I think for the students, right? I mean, this is a significant career path with so many changes also coming in, and especially within say organizations. I personally get to see that people make career even with just one product in security, right? That's a truth, right? Not just like sub areas like IAM, even products in IAM. Significant demand for experts for specific products itself, right? So it's such a large landscape, and especially with AI and security for AI agents and are coming up, it's a significant career path as well.
Thank you so much, sir. Dear participants, the feedback link has been shared in the group. Kindly complete the feedback form. As we reach the culmination of this enriching faculty enablement program, it is time to express our gratitude to everyone who contribute to its success. I now invite Ms. Ambli Mohan, Assistant Professor, Department of Computer Science and Engineering, Adishankara Institute of Engineering and Technology, and the co-coordinator of this faculty enablement program to propose the vote of thanks.
Good afternoon, all. It is my pleasant duty to propose the vote of thanks on this auspicious occasion of the valedictory session of our 6-day online faculty enablement program on industry practices in software development for complex interdisciplinary challenges. I would like to extend my gratitude to Mr. Dr. M.S. Murali, Principal ASIT, for his continuous encouragement and support towards faculty development initiatives. Thank you, sir. I also like to express my sincere gratitude to Dr. Supriya S., Dean Research, ASIT, for encouraging us to pursue excellence in teaching, research, and innovation. Thank you, ma'am. Our heartfelt thanks to Mr. P.B. Rajaraman, Chief Technology Officer, ASIT, for his encouragement and support. Thank you, sir. I express my sincere gratitude to Dr. Remanibhai V., Professor and Head, Department of Computer Science and Engineering, ASIT, for her valuable efforts in organizing this faculty enablement program. Thank you, ma'am. I would like to extend my special thanks to Dr. Deba Devasi, coordinator of the FEP, for her dedication and hard work. Thank you, ma'am. I also express my sincere gratitude to the sub-coordinators of the FEP, Mr. Anjush RK and Ms. Hida Roki, for their support and coordination throughout the program. Thank you. I take this opportunity to thank the management of Adishankara Institute of Engineering and Technology for providing all the necessary support and encouragement for organizing this program successfully. I also extend my appreciation to all the participants who joined us with enthusiasm and commitment to enrich their knowledge and professional competencies through this faculty enablement program. Finally, I thank the organizing committee, faculty coordinators, and technical support team whose dedicated efforts ensured the smooth and successful conduct of this program. With these words, I once again express my sincere gratitude to all our distinguished guests, resource persons, and participants for gracing this occasion with their presence and contributing to the success of this faculty enablement program. Thank you. Thank you all.
Thank you, ma'am, for the heartfelt vote of thanks. And thank you so much, Vinod, sir. Your session was an insightful session. Your discussion on the cybersecurity, secure software development, and risk management has provided valuable knowledge that is highly relevant in today's digital world. Thank you so much, sir.
Yeah, thank you. My pleasure. Yeah.
Okay.
Thanks for the time.
Yeah. Dear participants, as informed earlier, a test will be conducted now. The duration of the test will be 30 minutes, and participants must secure a minimum of 75% marks to be eligible for the certificate. The test link has been shared in the group. We kindly request all participants to complete the test before 2 p.m. today. So kindly complete the test. May the insights gained during this faculty enablement program continue to guide and inspire your academic, research, and professional endeavors. Thank you all for your enthusiastic participation and support. We look forward to meeting you again in future training programs organized by Adishankara Institute of Engineering and Technology. Once again, thank you all. Have a wonderful day.
Thank you. Thanks, everyone.
Thank you, sir.